Well, hello guys, here Mr. G with another video. This time we're going to be talking about acid and bases, mostly about the definitions and how to identify acid and bases, but we are going to only focus on the Bronsted-Lowry theory. We are going to be focusing on this theory. We're going to explain that one. Before that one, please subscribe for the channel so you can get all the notifications and videos I post on regular basis. So we're going to start straight to the point and we're going to define an acid according to Bronsted-Lowry theory. Okay guys, so according to Bronsted-Lowry, an acid is a substance that give away protons. Now protons refers the H plus ions and is therefore called proton donor. Now important here is that when they ask you what is an acid, you can just say it is a proton donor and you will get the full mark because it will be correct. Now what is a base? Alright, so we said that a base is a substance that takes up proton, also H plus, and is therefore called a proton acceptor. Once more, when they ask you to define a base, all you have to say is that it is a proton acceptor because it actually accepts protons. Okay, now let's see some examples so we can be able to identify a proton acceptor or proton donor. Now let's see here this example. Okay, we have this reaction HCl plus Na is going to give you NH4 plus Cl minus. Okay, now the first thing you are always going to do is to identify the families from reactants to products. So you can see that HCl is family of Cl. They are the same here. Something happens as you move from reactants to product, as you come in this direction there, guys. And the other family here will be the NH3 and the NH4. It's quite simple to see the similarity from reactant to product. So those are families, okay? So now what we're going to see, we are going to see what happened from reactants to product. So in the first case, you have HCl, and then on the product you have Cl minus. You can see easily here that one hydrogen is gone, is left over. So this hydrogen is gone away. Therefore, this substance here is an acid. Because from reactants to product, one hydrogen was given away. You can see it there. Now, what happened to the other substance? Now, the other substance is the NH3. You see is going to NH4 plus. All right. So you could see here that one hydrogen was being taken in. One hydrogen was taken in there. So this one then is going to be the base. So you have now which one is the acid and which one is the base in this chemical reaction. Is quite simple. Let's go and see another example just in case it is tricky. Alright, so here we have another example. All we're going to do first, as usual, is to identify the family. So you can see that this substance here is family of that one there from reactants to product. So it's going that way. That one here in the reactant was converted into that one, the other substance in the product. And we can see that the other family is the water here, the H2O and the H3O plus. They are quite similar, the families. So it's going to be this one here. So now we have to look what happened from reactant to product. Here we started with CH3, COOH, but we end in the product with CH3, COO minus. So you can see here that one hydrogen, you can simply see that this hydrogen, one hydrogen, which is this hydrogen, left the system here. It's gone. This specifically compound left that hydrogen away. Therefore, this one donated that hydrogen and is going to be the acid, as you can see from reactant to product, the hydrogen is gone. What happened to the other substance? Now you go here to the water, you started with water H2O, but then you end with H3O plus. You can see you're starting with 2 hydrogen, now you have 3 hydrogen. So one hydrogen extra was taken in there, and therefore this substance here is the base. Guys, I think it's quite simple how to identify acid and bases. It's not a big problem here. Okay guys, so now we are going to be able or to learn how to identify the acid base conjugate pair. So now we're going to be looking at something new here, which is the acid base conjugate pair. It is related to what we've done now. Okay, all right, so let's use this equation to identify the acid base conjugate pair. Let me tell you that that's the action we already were with it, but now we are going to ask more questions about it. So in this case, once more, we are going to identify the families. You can see those two are families there from reactants to product. And then these two here are family. Guys, this is just a way I found to make it quite simple, okay? That's all I see here. Now, if we go to the first part, which is this one here, you can see that from reactants to product, from here to there, 1 hydrogen was gone. So you can see that HCl lost 1 hydrogen. Like you can see here, this hydrogen there is gone. So this HCl is the acid. All right. Now the conjugate pair to that acid is chlorine. So this one here will be a base. Now not worry about that one. If this one is acid 1, this one is base 1. Now not to worry. How will look like this one? Will look like if this reaction is going in the opposite direction. So if it was from product to reactant, if this one was moving in this direction, guys, what would the Cl do? Well, the Cl here, as you can see, will have to take 1 hydrogen proton in to become HCl. So that one is how we identify the conjugate base there. You can see as you going from product to reactant. So that one is going to be the conjugate base to that acid. So this one is a base, but it's not just a base, it is a conjugate. It's a conjugate base. It is a conjugate base to that acid one. Let's see the next one. Now this one here is going from ammonia to NH4 to ammonium. You could see there, quite simple, that you started with 3 hydrogens, but you have 4. So this substance here has been taken a hydrogen in order to become NH4. Therefore, the NH3 is the base. Right? Let's use another color there. I like color. So this one is the base. And guys, once more, this one is base 2, for instance. Now, once more, if it was in the opposite direction from products to reactant, you could see that this one had 4 hydrogen, but then it ended in 3. So this one here will be the conjugate acid. Is the conjugate acid to that base, or acid 2. So it's quite simple, really simple, and there could be a question like this in the exam. We're going to practice some questions eventually. It's not a problem, but this one is all. This one is all I wanted to speak today, guys. This one is the definition of acid and bases according to Bronsted law. It's not the only definition, but this is the one I'm going to explain in the video. I don't want to go to the other one. You can go and look that one in the exams. How to identify an acid and how to identify a base, and most important at the end, how to identify the acid base pair. If you have the acid and the base identified in the reactants, then the product is quite simple because it's the families. The families will be the opposite. That's all you have to learn, and then I'll see you next time. Don't forget to subscribe for the channel. Next time we're going to speak about ampholyte, amphiprotic, and few important things. I'll see you next time. Mr. G here.